Okay, hey there. Welcome to my first portfolio, and thanks you guys for watching. This is Mars. I come from China, and I once worked for the Manulife Asian branch as a backend engineer, mainly focused on the cloud data engineering. And right now, I'm also a master international student studying in the Trent University, Ontario, Canada. My major is big data analytics. I'm strong and confident on the big data engineering, including the batch and stream processing, the data warehouse modeling, and the data lakehouse architecture, and cloud data engineering. And people often joke that the data engineers are the SQL boy. And honestly, yeah, I do spend a lot of my time to writing complex SQL query and coding in the PySpark, the Scala, and the Java in my daily work. But I'm lucky enough to have lead a real world data warehouse project managing around 100 gigabytes of the data daily and handle everything from the ETL jobs and the BI integration to optimizing the SQL computations and the scheduling the workflow. And those improvements actually help the team to cut the cloud computing cost by about 10 to 15%. Today I'm making this video to introduce my big data project for real quick. My first data engineering portfolio piece for job hunting. So I built this project in my free time while studying in the school. I just want to show that I'm 100% ready to handle the real world tasks in the actual company's data team. It's definitely not just a toy project. I tried my best to make it as close to the industry level standards as possible. If you check out my GitHub repository, you will see that my project covers exactly what the company's data team typically deal with every day. So for example, I've done things like the data warehouse modeling and design, the configuring the PySpark batch job with Airflow scheduling, the cluster setup and the maintenance, and optimizing the data storage and the computing performance, and the setting up the CI/CD pipeline. And basically everything that that would give you a clear picture of how I would perform in a real data engineering role. So in my GitHub repo, you will find everything clearly organized, including all the source code for the project and an overview of the project's core features and deliverables, and some diagram I designed, like the data warehouse, the dimensional modeling methodology documentations, and the architecture diagram for the data dimensional modeling, and my data platform architecture diagram. Yeah, so and also I that includes a lot of important screenshots showing how things look like in the Airflow, the ClickHouse, the Power BI, the GitHub Actions, and Grafana. So, and of course, I put lots of effort into documentation. I wrote detailed guides explaining my code, the development standards for the data warehouse modeling, and even the troubleshooting notes. You will get a clear sense of how I built this project from the scratch, including the challenge I faced, the weird issues that popped up, and how I solved those problems. And these are exactly the things we programmers are facing and handling every day. Alright, let me start by explaining how I built the cluster itself. I used the Docker containers to build a full big data platform completely from scratch. The setup includes a 3 nodes Hadoop cluster with high availability supported by the Apache Zookeeper. So basically, the Zookeeper helps us to manage the failover between 2 resources managers and 2 name nodes. The switching between active and standby mode automatically, just like you would see in a real world production environment. So on top of that, I separated all the big data services clearly by using a bunch of different containers like the Hive container, the Spark container, the Airflow, the MySQL Meta Store, and a monitoring container like Prometheus and Grafana. So if you look at my GitHub repository, first of all, you could download the images which I open sourced to the GitHub container registry, and you can get the Docker compose file, the container configurations files, and some DevOps scripts for the server container. So you could, by following the quick start instructions step by step with just one command, you can quickly launch your own mini big data cluster on your local machine and see exactly how it works. So, all right. A data warehouse is a company's core data asset. A lot of people know what a data warehouse is. They've probably heard about the dimensional modeling, the star snowflake schema, things like that. But not many people actually build a full data warehouse from scratch on their local machine, and even fewer create a complete, detailed methodology like I did. So in this project, I delivered a comprehensive data warehouse design document, including clear step-by-step instructions, and you will see how I did the initial business data analysis, how I identified the dimensions and granularity, built dimensional tables and factor tables by designing the best metrics, structured the data warehouse into different layers, and set the clear naming rules for tables and fields in the tables. I also show how to track the data lineage, manage the life cycle of the data tables, and more. So basically, I've documented the whole process clearly. Just check out my GitHub repo link. You will see exactly how I think, how I plan, how I handle the data warehouse project from the scratch. Okay, in many companies, the big data team mostly works with the batch processing of historical data. Usually, there are complex job schedule running every night. First, data is extracted from the business databases like the MySQL, the Oracle, or other relational databases, or maybe from logging system or APIs, and loaded into the data warehouse. And then the batch job starts. We clean the data, we mask some sensitive information data, and apply standardized a lot of things like that. After that, based on the data models we've already set up in the Hive, we write the clean data into the tables. We run lots of SQL query to aggregate, to summarize, to analyze, and move the data into the different layer according to the granularity for critical analytic data. Companies usually won't let the external BI tools or API directly access the Hive due to the privacy and the security problems. Instead, we often export the data into the special data marts or OLAP engines like ClickHouse. So in this project, I simulated exactly these kinds of ETL workflow and internal warehouse tasks. You will see how I use the PySpark to extract the data from the Oracle into the Hive, and also how I use the PySpark to push the data from the Hive to the OLAP engines like the ClickHouse. I will show how the Spark SQL and the Spark on Yarn perform the distributed modeling, the distributed computing, and how the Airflow manage the job scheduling through the DAG configuration, and how Grafana and Prometheus helps monitor the Hadoop cluster and MySQL database loads. Plus, I built a BI dashboard using Power BI connecting to the ClickHouse, making sure that the data analyst just need to 100% focus on the data insights without worrying about what's happening behind the scene. We all know the CI/CD tools are widely used in the software and development. Many companies use the Jenkins and GitLab CI/CD to handle the deployment and the operations. And honestly, the big data projects, especially the data warehouse engineering, not many teams fully integrate CI/CD into their workflow. So in this project, I just want to show off a little bit of my experience in this area. I set up a basic CI/CD pipeline using GitHub Actions to automate the deployment testing of my big data cluster. Basically, every time I trigger it, the pipeline checks whether the cluster service can start up and shut down smoothly without any issues. And to make this happen, I set up a self-hosted Linux runner on my local machine, so which my GitHub Actions could connect to for running tests. So, alright, to be clear, the CI/CD isn't the main focus of this data warehouse project, but I include it because I want to show you I'm 100% comfortable using those tools, and to highlight that I have practical experience integrating the software development practices as a data engineer. All right, a big part of the working in a data team is helping the company to save money on cloud computing cost. This involves two main areas, storage and computing cost. So for storage, we usually focus on the file format and compression. For example, we store data using the Parquet format, usually, which is very common used in the Spark jobs, and we apply the snappy compression, and this helps us to shrink the size of the data files on the HDFS, saving the storage cost. We also manage data very carefully, setting the clear rules for the data lifecycle management and governance, so we don't keep a lot of unnecessary and duplicated data around. Nobody wants their data warehouse filled up with old and unused data, right? And also for regarding the computing cost, it's very important to really understand how the Spark works. One big thing is to avoid too many shuffle, because the shuffle is expensive. It involves sending a lot of data across the network and write it onto the disk on the different executors. Instead, we used the tricks like the broadcast join, very famous, right? For the smaller tables, which lets us to skip the shuffle completely. Another important thing is dealing with the data scale, where the one particular key has way more data than other key, making everything slower. So we also apply the partitioning and bucketing to the Hive to organize the data better, so the query don't have to scan too much data each time. And also, the order sorting can also help speeding things up. So even though not every data engineer directly handles those cost-saving optimization every day, but it's still essential for us to understand what's happening behind the scene. You have to know your SQL query scan, how your SQL query scan the data files on the HDFS, how the data moves to the executor, and how the aggregation actually happens, right? if you master this optimization, your nightly batch jobs might finish half an hour or even an hour earlier, which give you your whole team more flexibility and room for errors. So monitoring and alerting. So honestly, this is probably what every engineer fears the most. Nobody wants to get a warning in the middle of the night or see the storage usage go over 90% because that usually means HDFS and the yarn might crash soon. In the cloud, we are writing tons of data and running heavy computations every day, which puts a lot of pressure on the disk I/O and network I/O, the memory, the CPU, and keep on. So we should make sure we are keeping an eye on the health of our cluster. It's super important. Yep. So that's why in this big data platform, I set up a Prometheus node exporter on all 3 Hadoop nodes and MySQL Metastore. This lets me let me pull the real-time performance data from each server using the HTTP. Then I use the Grafana to build a solid monitoring dashboard, as you can see, and connecting the alert managers to send alerts when something goes wrong, just like how things work in the real companies. So what I want to show here is that I understand how important the monitoring is in the data engineering, and that I have hands-on experience setting up this system. It's not just like about writing code. It's also about making sure everything behind the thing is running properly.